Okay, welcome you all back to our YouTube channel Science is Live. Today we hope to bring you a video about data types in C and variables and constants, as well typecasting in C. Okay, let's see. What are the data types that we can use in C programming? Okay, let's see. Yes, there are three types of data we can use in C. The first one is primitive data types, second one is derived data types, and third one is user defined data types. So the primitive data types are char, int, float, double, and void. So these are very basic data types that we can use in C, right? And there are derived data types as well. So these are derived data types. We can derive these data types using this primitive data types. That means the basic data types, right? So, and also there is a separate data type called user defined. These are struct, union, and enum. I will do a separate videos for these three topics. So in today we hope to talk about this primitive and derived data types. Okay, so when we talk about data types, you may heard char, integer, float, double, boolean, string, right? But I told you that here there are four data types that we can use in this uh, C programming. They are char, int, float, double, as well. I told you it is void, right? So char means what? Char data type is the most basic data type in C. It stores a single character and requires a single byte of memory in almost all compilers, right? And that means char represent in a char data type we can store only a single character, right? Only a single character. And integer, we use integer to store integer values. As well, we use float and double to store decimal numbers, right? These both used to store decimal numbers, but there is a little different from each other. Float will store with single precision, right? So float will store a decimal number with single precision, but double will store a decimal number with double precision. That is the difference between float and double, right? Then you may think that how can we store a boolean value? That some of you may know that we can have a separate data type in Java, that is boolean, but don't we have a separate data type for boolean in C? Yes, we have. We can have variable with bool, but we need to include the header file as stdbool.h, right? To have boolean variables, you need to include the stdbool.h header file into your source file. So I think you know it, how to include, right? So I have mentioned how to include header files in previous video. So you know, in booleans we stores true and false values, right? So true means 1 and false means 0. But in C boolean, 0 is stored as 0 and another integer is stored as 1, right? So it may be 5, 6, likewise any positive integer value to represent that it is a true, and it will represent 0 as 0, right? So that's about Boolean data types. And you may heard string data types as well. In Java there is a separate data type called string, but do we have a separate data type in C? No, we don't have a separate data type called string, so we need to use a char array, right? We will see them in a future in a separate video, so I'll explain them there. So for now you think that we need to if we need to store strings, then we need to use char array, right? And there is a separate format specifier for string. It is percentage mark and s, right? So I told you that there are derived data types as well, right? So what is a derived data type? A derived data type is defined using combination of qualifiers along with the primitive data type, right? So that means I told you that derived data types are derived from the primitive data types, right? So they are derived from the primitive data types with combination of qualifiers, right? Then what is the qualifiers? What are the qualifiers? Qualifiers are optional add-on to the basic data types, right? So they are used to alter the behavior and property of basic data types, yielding new type with new property and behavior, right? So there are two types of qualifiers. You can see here they are sign qualifier and size qualifier. We need to have two type of qualifiers. One is for sign qualifier and other thing is for size. One thing is for sign, then it is sign qualifier, and the other thing is for size, then it is size qualifier, right? So in sign qualifiers there are two categories. We have only two categories, unsigned and signed. So there are two sign qualifiers, unsigned and signed. As well there are two size qualifiers as well. They are long and short. So we represent size by size qualifier. Then there are two size qualifiers. It is long and short, right? So how can we represent a derived data type? We can represent like this. First we can indicate the sign qualifier, then we can indicate the size qualifier, and last we can mention the data type we use, right? So as an example, there is a derived data type. This is unsigned short int. You may see there are lots of derived data types I showed you before. So this is an example of them. So here this is what? Sign qualifier. So it is unsigned. And this is the size qualifier. It is short. And this is the data type. The basic data type. It is integer. So by the combination of these three, we get an derived data type unsigned short int, right? So here I have mentioned all of the data types that we can use, and there are format specifiers that we can use for each of these data types, right? So go through this table and find what you need. Then here I have mentioned the size of each of these data types and the ranges of these data types, right? So go through this and learn about them also. So here I have mentioned the value range of float, double and long double. Here you can see float will gives you 6 decimal places, while double gives you 15 decimal places and long double gives you 19 decimal places. So you can see that the range is increasing when it is comes to double and when it is comes to long double. And there is a separate operator called size of that we can use to find out the size of a data type, right? If you don't remember the size of a data type, then you can use this size of operator. So what is the meaning of the size? Size means that how much space that particular data type uh, allocate from the memory, right? So that means how many bytes needed in memory to represent the type or value or expression, right? So let's see how this operator works. So here I have written some statements using printf function. So here I am going to do is that I am going to print the size of the data type char, right? So I am using size of operator to print the size of data type char. So in the format string I am typing size of char and equal mark. Then I need to print the integer value of the size of the char, right? Why do I use integer here? Because size of operator returns the size in integer values, right? That is why I use integer here. Likewise, I am going to print all of the data types sizes, right? So that's why I printed all of these things. So let's run these programs and see what are the outputs. Here now you can see that the size of the data type char is 1. That means when there is a data type char, it allocates single bit in the memory, right? So for data type char, it allocates only a single bit in memory. So how many bits allocated in memory for the data type short? It is 2, right? Likewise, for int, it is 4 bits in the memory. Likewise, these all values will indicate the size of the memory, size of the bits in memory which they will allocated, right? Then how to take the ranges of each and every data type? I told you there is a range, separate range for each and every data type. So how to print those ranges? Here I have used printf functions and within the format string I have printed as range of signed char, and I am going to print it in integer data type, right? In integer data type, the minimum and maximum size, right? So how to get the minimum value? So this is a constant, that predefined constant in C, right? Because this is in upper cases, so here you can say hash define char min, right? So this is already created as a constant in C, right? So we can directly use it by mentioning the name of that constant. I will teach you how to declare the constants, then you will realize how this constants also working on, right? So here there are predefined constant for string char, sign char minimum and as well sign char max, right? Likewise, there are several constants for each and every data types minimum and maximum range. So let's see what will we receive as the output when we run this program. Here you can see the range of signed char is between -128 to 127. right? You need to know this thing, that the range of each and every data types will depend on the compiler that you have in your computer, right? It will depend on the compiler. That means two compilers may have two different ranges for same data type, right? So for in my case, uh, these are the ranges for my compiler, right? So range of sign char is minus 128 to 127. Likewise, you can see the ranges. Here you can see the range for float is these two numbers. Sorry, these two numbers, and you can see the range of double and the range of long double, right? So that is how it works. Okay, now let's see how to use variables in C programming, because the variables plays a very majority role in programming. So how to use variables in C programming? To use variables, first we need to declare a variable, right? Then we should initialize a variable. After that we can use these variables in an expression, right? So let's see how to do these things. Now you know that there are several data types in C. Then let's see how to declare variables for each and every data type, right? Assume that we are going to have a data variable with data type int, right? So I am going to declare a variable right. This is how we declare a variable. First we should mention the type of the data, then the name of the variable. So here I named my variable as my variable. So what is the name of my variable? It is my variable. And what is the data type of this variable? It is integer, right? So in future I can assign a integer value into this variable, right? Variable means what? The value of the variable will vary by time, right? We can change the value of that variable. That is why we call it as a variable, right? So in any time I can change the value of this variable, right? So still it is not assigned into any value. It is just just the name of the variable. By declaring a variable from a particular data type, then the program will allocate some space from the memory according to the data type of this variable, right? So we know what is the size of the integer. What is the size of data type integer? It is 4 bits, right? So if we create a variable from the data type integer, that means it allocates 4 bits in memory, right? So here I have declared a variable called my variable. So my variable will take 4 bits from the memory, right? So the compiler will allocate 4 bits from the memory for this my variable, right? So how to assign a value into this my variable? You can do at the very beginning also. If at the time when you declare the variable, you can assign a value into this. So here I have assigned integer 5 into this my variable, right? So if you want to assign this value later, then you can do it like this, and you should type the variable name, and then you can assign the integer value into this variable. So here this is the declaration of variable, and this is the initializing of my variable, right? So if you want, it will depend on the situation of yours. If you want, you can assign it at the time when you declare the variable, or you can assign value later for that variable, right? So that is how declaration and initializing of the variables. Then you can declare any variable from any data type. If you want to declare variable from the float, then you can declare a variable and assign value into like this. And there is another thing that you need to know, that you can declare more than one variable for separate data type using commas, right? Like this. Like this, right? So here I have used same data type, integer data type, for all these 4 variables, right? I have declared all of these variables for same data type. I have separated them by commas, right? And also you can assign values into these variables too, like this, if you need. The thing is that the data type for all these 4 variables should be same, right? So you can't put commas and do it like this, then it will give you an error, right? You can see that there is an error. You can't separate different data types by comma, then there should be a semicolon, right? That is why we will receive an error here. And there is another thing that you need to know. If we don't initialize variables, just we only declare the variables, then I told you that then there will be a allocated space for these variables, right? But there are no values in there, so there will be a garbage value, because there is a space and there is no value. Then there will be a garbage value. Automatically there will be a garbage value stored there, right? If we print this my variable, then you will see that there is a garbage value. Now you know how to declare and initialize the variables in C, right? For different data types. Then let's see how to declare constants. What is a constant? Constant means it doesn't varies its value, right? In variables they varies the value of the variable, but in constants they do not varies its value. So how to define these constants in C? We can use 2 methods. The first one is using const keyword we can declare a constant, right? The second method is we can use hash define preprocessor to declare constants, right? So let's see how to do this thing. I told you that there are 2 methods to declare constants. Let's see the first method. by just use const keyword. Then I need to mention the data type of my constant. So my data type is, the constant's data type is integer. Then I will give a name for this constant. I will give const1. Then I will assign a value into here. I will assign 3, 5, 6. This is my constant, right? So this is my constant. Then let's try to change the value of this constant. Then you can see that there is an error when we change in the value of this constant, right? Because it is a constant and we can't change the value of this constant, right? So that is the advantage of using constant. If we accidentally or by mistake if we change the value of the constant, then we will receive an error, right? Let's try the second method by using hash define preprocessor, right? Using hash define preprocessor, let's say our constant is const2 and I am going to give it as 56.98, right? This is my constant. This is the name of my constant and this is the value of my constant. I am using hash define preprocessor. Let's try to change the value of const2. You can see again we can receive a error message because we can't change the value of the constant, right? Okay, that's how we can declare constants. The last thing we learn in today's lesson is typecasting. You will face some situations that you need to cast your data types from one data type into another data type. Let's see when we can cast data types. When you're dealing with several data types, then it is a very important thing that you need to use these data types very carefully, right? Otherwise you will have wrong outputs and you will confuse what is happening, right? So let's see a case like this. Then here I have declared a quantity variable named quantity in the data type integer. Here I have assigned integer value. As well, I have created unit price variable from the float data type and I have assigned value as 14.36, right? Then I am going to calculate the price. So I need to have a separate variable for price. Then I have created the data type of this price as integer, right? Then I am calculating my price by multiplying quantity and unit price. So unit quantity is in integer data type, unit price is in float data type, right? My price is in integer. So let's see what will happen by running this. I am going to print all of these things. So because of my data type of price is integer, I am here using format specifier for integer, right? So let's see how it gives the output here. you can see that here my quantity is 5, unit price is this 14.36 and zeros. Then my total price is integer. It is correct, right? So here I received an integer. What is the value of this integer? It is 71, right? So let's see what would be the output if we use the price in float data type. So let's change the data type of the float price into float, and I need to change the format specifier as well. Then let's run. Now you can see that there are decimal points, right? It is not exactly 71. We have decimal points as well. If we use float, then we can have the exact value of the answer, right? It is 71 point this, right? But if we use integer, then it will ignore all of these decimal points and it will round up into the nearest integer, right? It will ignore the decimal points and round up to nearest integer value, right? That is what will it happen if we use integer for price, right? Then let's see another case. Here I have created 3 variables for subject mark 1, subject mark 2, subject mark 3 from integer data types, and I have assigned values into each of these variables, right? So here I have a separate variable for average because I am going to calculate the average of these 3 values, right? So I am creating average for variable from float data type, and I am assigning average like this by calculating the summation of these 3 variables and dividing it by 3. That is how we take the average now. Then let's see what will be the output. See it again. My subject marks are integer and my average is in float, right? Then I am hoping to have a float average because if we divide the summation of these 3, it will have decimal points now. So I hope to have the decimal number. That is why I created average in float data type, and now I am going to print the value. Now you can see the average is in floating points, right? But we are receiving zeros as the decimal values, decimal points, right? So is this value is correct? Is it exactly 26? No, there should be more decimal numbers as well, decimal points as well, right? So what is going on here? When we add 3 integers, then we will receive integer total, right? So this summation of these 3 integers, we will receive an integer value. Then again we are dividing it by a integer, right? Here 3 is also an integer, so we are dividing integer by a integer. Then what will be the result? Then it will also be a integer, right? So that is what happened here. So this gives an integer, but we are printing a float value, right? That is why the integer value prints with 0 decimal values, right? So that's what happened here, but it is not correct answer, right? It is incorrect answer. So how to get the correct answer? We need to cast this integer value into what? into floating point, float data type, right? So now let's see what would happen. Now you can see that the decimal numbers are not zeros, they have some values, they are 6, right? So now we receive the correct answer. So in cases like this, we can cast a variable from one data type into another data type. Here our value is in integer, right? Our final value is in integer. We are casting it into float to assign into this float variable, right? So here we converted integer value into float value, right? That is what casting means. Such cases like we manually cast variable from one data type into another data type, then we call it as explicit casting, right? Here we done a explicit casting. There is another casting called implicit casting. Then the compiler automatically casts a variable's data type from one data type into another data type. Let's see when we can see here implicit casting. Here you can see that I have created a char variable. The name of my char variable is ch, and I have assigned value as simple a into this ch variable, right? Then I am going to do a calculation. I have created a variable called val and named the data type is integer. Then what is I am going to do is I hope to add the ch variable's value and integer 10, right? So I am going to add 10 into the value of ch variable, right? So what is the value of my ch variable? It is a. Can I add 10 into a? Yes. What is the value of a? I mean ASCII value. What is the ASCII value of a? It is 97, right? Simple as ASCII value is 97. So we can add 10 into 97 and have a value, right? But compiler automatically cast this data types char data types into integer data type, right? Then let's see, will it happen? Yes, it gives output as 107, right? It gives us an integer value 107. So that means it automatically cast it from char data type into integer data type. So this is a case we can see here, implicit casting. So that's all for today's lesson. So I hope you learned what are the data types and how to declare variables and constants, as well how to type casting in C programming. So I hope to see you again in another video. So thank you all for watching.